Welcome to today's video Medical Immunology lecture series. I'm Wang Qinghui from the Department of Immunology, China Medical University. It's my great pleasure to study with you together. So today I would like to give you a brief introduction of medical immunology history. Medical immunology is a basic subject which is derived from the subject of microbiology. Immunity, as you know, is a word derived from the Latin term immunus, meaning exempt. That is a state of protection from infectious disease caused by virus, bacteria, parasite, and fungus. When we talk about medical immunology, we have to mention very serious infectious disease, smallpox, which is caused by smallpox virus. Smallpox is very serious infectious disease, and it is a fatal disease. Many people suffered from smallpox. They suffer from the headache, fever, back pain, and finally they got eruption on the skin. So we can see a lot of the eruption on the face, chest, and arms. They covered with the smallpox. People try to find solution to prevent this kind of disease. And it was observed that some people were very lucky. They can survive. And those survived patients will never get infected the same smallpox again. So our Chinese doctors are very clever. They think if the recovered patient will not get infected again, so they must produce something helpful. So they prepare the components from the smallpox and put them into the nasal cavity of a healthy child. By doing so, this child is protected. And it was a very great work. It protected people stay from the smallpox. But unfortunately, it didn't always work well. A very good and safe prevention would be attributed to the British physician Edward Jenner. Edward Jenner observed such a phenomenon. He observed that the milkmaids developed a similar disease, which is called cowpox. But symptoms of the cowpox is much mild. And cowpox cannot leading to the death of the patient. So he prepared the components from the cowpox and introduced the component into an 8-year-old boy. Finally, the boy is protected. This method is called vaccination. Vaccination with cowpox dramatically reduced the incidence of smallpox worldwide. Although we don't know the reason, it opened a new area of the medical immunology. Another great advance is the induction of the immunity to the cholera. Louis Pasteur from France established a model of cholera. He cultured the bacteria of cholera and injected chicken with the cholera. Then the chicken died of the cholera. So one time after a summer vacation, Louis Pasteur and his colleagues returned to his lab, and they want to establish the model again. They didn't get fresh bacteria, so they used the old bacteria to inject it into the chicken. And the chicken got ill, but finally the chicken recovered instead of death. So Louis Pasteur thought maybe because the bacteria is too old, so the virulence is weakened. And then he prepared the fresh bacteria and injected into the chicken. Because he has a limited number of the chicken, so he used the fresh bacteria, injected both new chicken and recovered chicken. To his surprise, the new chicken died, and recovered chicken, that chicken exposed to the bacteria before, are very healthy. So Louis Pasteur used the experiment to prove that the weak virulence, the pathogen with weak virulence, which is called attenuated strain, might protect against the disease. And this attenuated strain is called vaccine. It is from Latin term vacca, meaning cow, in honor of the Edward Jenner's great work with cowpox inoculation. In addition to the cholera, Louis Pasteur also developed attenuated vaccine to prevent anthrax and rabid dog. The method to use the attenuated strain to prevent disease is called active immunity. So he established the method to gender the active immunity. It marked the beginnings of the discipline of immunology. From then on, a lot of scientists did remarkable progress for the development of the medical immunology. For example, Bering from Germany discovered the antitoxin in the serum. This antitoxin combined with the toxin for diphtheria and tetanus. Therefore, he established the serum therapy to treat the infectious disease. He established the passive immunity. It also starts the study of humoral immunity. Nowadays, we know it is the antibody in the serum to prevent the disease. Another great scientist, Machnikov from Russia, he observed phagocytosis by the phagocyte. He thought, except the soluble molecules, some certain type of the immune cells can perform the function, which are very important to our immunity. So he observed that the phagocyte can ingest organisms, microorganisms, that is called phagocytosis. So he established the basis of the cellular immunity. Next, it is Burnett from Australia. He proposed the clonal selection theory. In his theory, he said, as you know, we have a lot of lymphocytes in our body, and individual lymphocyte can express the unique receptor. This receptor combined with the antigen specifically. So an individual lymphocyte expresses the membrane receptor that are specific for distinct antigen. That is the basis of adaptive immunity. And this unique receptor specificity is determined before the lymphocyte exposed to the antigen. In another, he found during the development of the lymphocyte, some lymphocytes can recognize the self component. Those lymphocytes will die, and they will not grow into the mature lymphocyte. And only those recognize the foreign antigens, those lymphocytes can become mature. So the lymphocyte, the mature lymphocyte, recognize the foreign substances, can survive. And this is the basis of the immune tolerance. This slide shows many Nobel Prize winners and their great works. They did remarkable work for the immunological research. They are worthy being remembered, and they push our development of the medical immunology. That's all for today. Thank you for your attention.